So, you got a quiz tomorrow. You will never guess what that quiz is going to look like. That bell work right in front of you. Yep. So this bell work right here is what your quiz will look like. The quizzes, as I've said a few times, you're starting to get used to it. They should never be surprising to you. When you get to a quiz, you should be like, yep, this is exactly what I thought it was going to be. The problems are different, but they're exact same vibe. How about I do one on the board here with you guys? Now, as I've mentioned, you will be given this chart. I copied and pasted this exact chart on your quiz tomorrow. So you do not have to memorize anything inside of that chart. James, you want to grab that little bell work on the front table right there? One ahead. Yep, there you go. But you'll notice that it is missing time conversions. So I am expecting when Kira walks in and take the quiz tomorrow, I am expecting that she knows there are 60 seconds in a minute, and there are 60 minutes in an hour, and there are 24 hours in a day. That kind of thing. Does that make sense? So let's do this first one together. Notice that it won't be coming from the conversions table, so I'm assuming you guys know these time ones. 567 seconds over 1. Do I want seconds in my final answer? No, I do not. So what has to be on the bottom of my next fraction?
Second.
You got it. What should I try and convert those to?
Minutes.
Minutes, yep. Inching myself closer to hours. So now it becomes obvious to me, hey, does that 60 go on top or bottom? Which one does it go on? The bottom, because it goes with seconds, because there's 60 seconds in a minute, not 60 minutes in a second. Yep. Do I want minutes in my final answer? Nope, so those got to go too. How do I get rid of minutes?
On the bottom.
On the bottom of the next fraction, yep. So I got minutes down here. What should I convert those to?
Hours.
Hours, you got it. And we notice, okay, 60 minutes in 1 hour. So the 60 goes on bottom again. Just happens to be the case. Do I want hours in my final answer?
Yeah.
You betcha. So I'm done now at this point. I'm going to go ahead and multiply through. So if I give myself a little bit more space here. So if I do 567 times 1 times 1, I'll get 567 hours on top. 1 times 60 times 60 is 3,600. What does that fraction come out to be, somebody? 567 over 360? Or 3,600? Excuse me.
0.16.
Yep. And I believe your calculator says 1575, but you can just give me a couple of decimals. I'll teach you rounding today. You do not have to round officially, or properly, I should say, on your quiz tomorrow. Don't worry about that. Okay, I'm not going to count any answers off if it's just a rounding thing. So I could just go with 0.16. Of course, I like to box up my stuff. 0.16 hours, good enough. How about I put a few minutes on the clock? You guys get cooking on this. I'll come around and check in with each one of you individually. Your answer key is the pink sheet on your desk. Some of you guys need replenished. If you're watching this video at home, the answer key is right below the video. So please let me know if you have any questions with that. Your quiz will look just like this tomorrow. It's only 5 questions, so it shouldn't be too bad. But we're going to go ahead and move on to some new notes. I would just love for you guys to start your notes by writing down the multiplication table for the number 4 for numbers 1 through 7. So go ahead and write down those 7 math problems for me. We want to make sure that our math skills are up to snuff. And you can title these notes, by the way, Sigfig notes. So go ahead and knock out that multiplication table for me. We're going to talk about it here in 60 seconds. Let's see here. Severin. 1 times 4, what is that? Look at you, smarty pants. Love it. Pranita. 2 times 4. Look at you. Going back there. Workman. 3 times 4. Wow. Wrong! Wrong! That's wrong. That's wrong. 3 times 4 is not 12. I hope I just broke the microphone. Haley, would you help him out, please? He just said that. 3 times 4 is 12. Are you listening to yourself? That's crazy talk. Abby, please.
Triple of 4.
A triple of 4?
Yeah.
Like the words? Like the phrase?
Yeah.
Guys, I just want to know what 3 times 4 is. That's all I want. That's all I want. Someone please help me.
72. 6.
3 times 4 is 72. 24. 6. 21. What is happening? 10? 7? Which one of these answers is it?
None of them.
It's actually 10. Look at her. She's all excited. Yeah, guys, everyone knows that. 3 times 4 is 10. Duh. Oh, I'm getting a phone call. Quick pause. What's 4 times 4, buddy?
Oh, 12.
4 times 4 is 12.
Okay, well,
What do you think it is, Parker?
is it actually 16?
No, it's not 16. Guys, you guys, come on. Come on.
14.
You, I'm sorry, did you say 4 times 4 is 13? That's a prime number. Are you listening to yourself right now?
17, 12, 18, 19, 20, 20. I could do this.
Oh, this is hurting.
2.
I can count all day. Guys, everyone knows it's 20. Everyone knows it's 20. Oh man, Hudson, will you please tell me what 5 times 4 is? And I swear if you say 13, I'm going to lose my mind. I might just lose it. 5 times 4 is 30?
Yeah.
2.
I'm hurting. 2? Right, yeah. 5, which is bigger than 2, and 4, which is bigger than 2, multiplied together equals 2. Alexa? If I feel like it. Actually, yes. By the end of the period, I'm hoping you can do this. She's like, please? Izzy, why don't you explain this one for me? 5 times 4? I don't want you to yell at me. Oh, no. It's not 16. Guys, come on. It's 20. Duh. Everyone knows that. 5 times 4 is 20? You're like, but wait, but the 4 times... I bet you did. I bet a lot of you guys did. And yet you were afraid to say it. This makes sense now, right? Are we good?
Yeah.
Back on track?
Yeah.
Feeling great? That's cool. Hey, this one's 20, and that one's 30. Great. Let's go ahead and take our notes here. We're going to have a quiz over Sigfigs on Friday. So don't worry, we'll do a lot of practice between now and then. Who's feeling frustrated? Yes, lots of paws are going up. Well, I will explain, I promise. So significant figures, and by the way, whenever you see this, you can always just write Sigfigs. It's much easier, and I always just say Sigfigs. And errors associated with measurements. Alrighty. Here's some things that we want to talk about. Why did you do that to us, Mr. Pilcher? What is Sigfigs? Why do we have to do this? Why? Why are you evil? Do you like yelling at students? Answer is yes. I find it very amusing every time. But there's also a reason behind it. Sigfigs tell us how good our data is. And they tell us how good our tool is. They tell us how good our data is, but they also tell us how good our tool is. So without ever meeting a person or ever observing the experiment that they're doing, by looking at their Sigfigs, you can talk about the strength of their data and the strength of the tools they're using. How good were they? How good were they? Mr. Pilcher, I'm just getting more confused. That's all right. We're going to go further down the rabbit hole, but hopefully you're on top of the mountain by the end of the period. So you guys remember these rulers last week? Certainly don't have to draw those. So this ruler right here was trash. In my humble opinion. It didn't really help you very much. It went to the tens place. That was it. And this one was a little bit better. It wasn't great. It was more of like a meh. Then when I give you guys the nice plastic rulers, you'll be like, okay, that's pretty good. And you guys remember how our measurements changed each time we measured, okay? And it's not that the person measuring changed. It's not that the shape that you guys were measuring, which last week we were measuring rectangles and triangles. It's not that the shapes changed. The only thing that changed was your tool itself. Okay? So your measurement was improving, is becoming more precise because of your tool and your tool alone. So, let's talk about exact numbers now. This slide, by the way, will make you feel a little bit better. We're going to get a little confidence boost, and that's not a trick. You're going to get a little confidence boost. So exact numbers, counted numbers, a given or a constant, or conversions. So exact numbers include counted numbers, givens or constants, or conversions. And I'll show you examples of each, just to clarify what I mean. So for example, when I tell Trinity, hey, the area for a triangle is 1/2 base times height, that is exact. That is a formula. There is no error involved in that formula. That is exact. Or when Pranita counts 5 dimes, 1, 2, 3, 4, 5, that's an exact number. Counting is exact. It's not like, well, we kind of estimate it. Like, no. You either know it's 5 or it's not. It's exact. Or conversion, for example. So this is in your conversion table. That will be on your quiz tomorrow. It was also in your bell work earlier this period. 2.54 centimeters by definition is exactly 1 inch. Exactly 1 inch. Not almost 1 inch, not about 1 inch, but it is exactly 1 inch. That's a conversion. 1 foot equals 12 inches. Conversion. 1 milligram equals 0.001 grams. That's a conversion. It's exact. There's no measuring happening. And so these have no error. No error. However, whenever we're talking about estimated numbers, we're really referring to an observed value or quantity. And what I'll highlight here is what you should write down, aka measured values. So measured values are always estimated. This makes sense from last week. Remember how I told you, how do you know when you're done measuring something? How do you know when to stop writing down numbers? Once you estimate that one time, right? The moment you estimate, you know you're done. Which means that every time you measure something, you always have to have estimated at least once. So they always have error. So an exact value never has any error. A measured value is always estimated and therefore does have error. Therefore does have error. Mr. Pilcher, I still don't get why 3 times 4 is 10. You will. You will. I promise. So you're about to have a worksheet come around to you. And on that worksheet, we have a top section where you label these 10 questions as either exact or estimated. Let's go ahead and put 30 seconds on the board, see if you can knock out a few of these. Let's try some of these. All right. So, Izzy, somebody counted 132 people. Is that exact or estimated? I would say it's actually exact because it was a counting one. And that's the first one. People usually get a little confused. But there's no measure involved where they had to estimate at the very end. They're like, oh, is that a person or not? They're just like, that is exactly 132 people. Does that kind of make sense? What about when someone has 24.1 centimeters? That's estimated because they estimated that one at the end, okay? That's why they stopped writing down numbers when they were measuring. Like, okay, I know it's 24, and I'm pretty sure it's 0.1 centimeters. It might be 0.2, but I'm pretty sure it's 0.1. What about someone that's talking about 800 miles long, Alyssa? What would you say? Estimated exact? Did they count that or did they measure it? Probably measure, so what would you say? Yeah, there you go. Just sort of work your way through it. Like, did they count that? Did they measure that? Blaine, 10 times. Right, because that's somebody counting. That's somebody counting. That's estimated. That last 0 there must have been estimated by that thermometer that was measuring. We count a dozen eggs, though, so that's exact. 1,000 milligrams to 1 gram, that's a conversion, so that's going to be exact. That's a definition. A milligram, by definition, is 1,000 times smaller than a gram. This is also a conversion. That's also a conversion, so all those are exact. But then when we say about 39 inches, okay, also we're talking about estimations, and so that's an estimation. All right. Now you missed any of those, but the answer key will be floating around here soon. But let's go ahead and talk about the rules for significant figures. The rules for sig figs. There are some rules. The first one is very easy. You will feel great about life after this first one. Non-zero numbers. So anything that's not a zero, 1, 2, 3, all the way up to 9, any of those guys are always significant. There are no exceptions. There's no weird situations. There's no trickery of any kind. Just simply put, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any of those numbers are always significant without a single exception in this world. They're always significant. Always, always, always. So let's say we had these three measurements. You can feel free to write these down if you want. So 2, 4, 7, how many non-zeros do you guys see there? There's, how many non-zeros do you see? I see 3 non-zeros. 2, 4, and 7 are all not a zero, if that makes sense. So I would say that this has 3 sig figs, except for sig figs. 0.1491, does the decimal do anything? It tells you about the size, but in terms of non-zeros, it doesn't do anything. So that would be 4 sig figs, a 1, a 4, a 9, and a 1. 23.567, how many digits do you guys see? They're all non-zeros, right? So this would have 5 significant figures. 5 significant figures, yep. And that's it. Pretty simple so far, yes? It gets a little saucy when you start talking about zeros. A little bit of sauce coming your way. Leading zeros, okay? So there's 3 flavors of zeros. Leading zeros are never significant. Leading zeros are never significant. Leading zeros are never significant. What do you mean by leading zero, Mr. Pilcher? If you take a look at these 3 values here, and you can maybe just write down one of those. You shouldn't have to write down all those zeros on that last one. A leading zero is a zero that has no non-zeros in front of it. No non-zeros in front of it. So do you guys see how 0.0000543 has 4 leading zeros? Because there are no non-zeros in front of them. So none of those count as significant. So where are the significant numbers here? The 5, the 4, and the 3. So that just has 3 sig figs. What about if there's a 0 before the decimal? It doesn't matter if there's not a non-zero before it. It's a leading zero, and leading zeros are never significant. So we only have 2 sig figs. They're right there, the 9 and 3. This guy right here, those are all leading zeros. Doesn't matter how many of them there are, they're all leading. So this is the only significant figure. There's only 1 sig fig. Now, if someone were to come in here and plop a 1 right there, that would change everything. Okay? That would change everything. Those are no longer leading zeros. And we'll talk about what that means. But as long as there's no non-zero in front of them, they're leading zeros and they don't count as significant. That brings us to captive zeros. Captive zeros. Or sometimes people call them sandwiched zeros. Captive zeros always count as significant. Always, always, always. Unlike leading zeros, which are never significant, captive zeros are always significant. What is a captive zero, Mr. P? Well, it's any zero trapped between 2 non-zeros. 7,004. 7's a non-zero, 4's a non-zero. Everybody trapped in between them, no matter if they're 0 or not, are significant. So all these are significant, 4 sig figs. All these are significant, 6 sig figs. All these are significant. Those are captive zeros, 5 sig figs. So, leading zeros are never significant. Captive zeros are always significant. And that brings us to our last type of zero, trailing zeros. Trailing zeros are sometimes significant. So these are probably the most difficult ones for people to figure out. They're a little tricksy. A little tricksy. They count only if there is a decimal. I'm going to highlight only if there is a decimal. Trailing zeros count only if there's a decimal. Only. Only. So, numbers with a decimal. So here we go, 10.0. It's a trailing zero because there's no non-zero after it. But is there a decimal in 10.0? Does it have a decimal? Yes, it does. So that means all these are significant. 3 sig figs. 0.15430. That's a trailing zero at the end because there's no non-zero after it. Is there a decimal somewhere in that number, though? Yes, there is. So that means all of these are also significant. 5 sig figs. 100,000 point. A bunch of trailing zeros. But is there a decimal? You betcha. So that means all of these are significant. That would be 6 sig figs. Mr. Pilcher, what does that decimal even mean? Here is exactly what a decimal means. That decimal means, this is what this person's trying to say. Hey, look, I know 100,000 looks suspicious, like I just rounded off. But when they put that decimal, they're like, hey, I actually measured those zeros. I measured those. So this person is saying, I know that's a 1, and that's a 0, and this is a 0, and that's a 0, and that's a 0, and I estimated this very last one. I'm pretty sure that's a 0 too. It just happens to land on 100,000, which I know looks suspicious. But I actually measured those. That's what that person's saying. Now, however, if I just take a teeny little bit of white out here, I go like this. Now, all of a sudden, we're forced to assume that that person just rounded to 100,000. I'm like, oh, okay. Well, we don't really know if they measure those zeros or not. And so it's a different story. So, without the decimal, so that 10 meters, did that person actually measure that zero? Yes or no? I don't know. If they would put the decimal, they definitely did. I'm forced to assume that they didn't. So this only has 1 sig fig against that one right there. 1960. Well, I mean, they might measure that zero, but they didn't put the decimal and tell me they did. So I'm forced to assume they're like, yeah, it's definitely 1,900 something. I'm pretty sure it's like 60-ish. It might be 50-ish. I'm not really sure. So this only has 3 sig figs. Over here, the 100,000, no longer with the decimal. We're forced to assume that they just rounded to closest 100,000. So maybe this is like 110,000 or something. I don't know. But this only has the 1 sig fig right there. Uh-oh. The 1 sig fig right there. Hey, how many sig figs would this have if I put that little decimal right there? 6, right? All those zeros would all of a sudden become significant. Without that decimal, they're not significant. So these last 3, you don't have to write down these 3. 300 meters. This person, did they put the decimal?
No.
No. Do we know if they measured those zeros or not?
No.
No. So we're forced to assume they didn't. And they're just saying, oh, yeah, it's about 300. This person, 300 point, they're like, it's definitely 300. And I'm pretty sure it's like 300 on the dot. It might be 301, but I'm pretty sure it's 300 on the dot. This person, they put that dot and then they continue to put zeros. Why would they put those zeros unless they actually measured it? They're not doing anything unless they actually are showing, hey, I measured those. So this person knows all the way down to this zero. They know. And then this very last one, why did they stop writing? Because they finally estimated, right? That last one must be estimated. Okay? Mr. Coacher, I still don't get how this has to do with 3 times 4 equals 10. You will. Oh, so soon. So I want you to move to this section of your paper. We're just going to practice counting our sig figs. I'm going to do the first 4 with you. 137. Do you see any zeros?
No.
Me and okay, so I don't even have to worry about the whole decimal situations. But yep, those are all significant. And I'm just circling these. Here's a decimal, but it doesn't matter because there's 0. Hey, 101, what kind of 0 is that?
Sandwich.
Sandwich, okay. Is it significant?
Yes.
Always is, so all these are significant. 810, what kind of 0 is that? Trailing. Is there a decimal? So do we know if they actually measured it? We did not. So 810 is actually only have 2 sig figs right there. Why don't you guys try a few rows of these? I will not give you enough time to do all of them, but you can do a few rows and see how you're doing. The answer key is below in the video, by the way, so you can check, and I'll bring the answer key around to you guys if you want it. Let's just do one more row together. 620, what kind of 0 is that?
Trailing.
Is there a decimal?
No.
Do we know if they measured it or not?
No.
So we're forced to assume they did it. And so they estimated that to 26.10. That is a trailing decimal, or trailing 0, but there is a decimal. So we're assuming that they did in fact measure that 0. Boom. 0.002, what kind of zeros are those?
Leading.
Leading. Are leading zeros ever significant?
No.
Nope. It's just that 2. And this one's got a mixed bag, okay? These first 3 zeros are leading, but some of them are after a decimal. It doesn't matter. If there's no non-zero in front of them, they are leading. This 0 right here, though, that is trailing. Is there a decimal?
Yes.
Yep, so that last 0 does count, because there is a decimal somewhere in a number. It doesn't matter where the decimal is, as long as there's one somewhere. And so these 3 are significant. Those first 3 zeros are not, though. Let's go ahead and move on. We're finally about to learn about 3 times 4. Okay. So here's one for you. What's 3.0 times 4.0? It's 12. Feels a little bit better? I still don't understand. What about 3.00 times 4.0? It's 12. Hold that thought. What about 3.000 times 4.00? 12.0. 3.000 times 4.000? 12.0. But what about 3 times 4?
10.
It's 10. Mr. Pilcher, I'm just getting more confused. You are not carrying out your promise. You said you promised I'd understand, and I don't understand. Let's talk about the rule, and we'll come right back up to that chart. Here's the rule. The number of sig figs in the weakest measurement, the weakest, the worst, controls or limits where you round. The number of sig figs in the weakest measurement, the weakest, the worst, controls where you round. Yep, still not getting it, Mr. P. Still not getting it. Let's go back through this little chart right here. Let's see. Blaine, how many sig figs does 3.0 have? It has 2, right? Nice save because it's trailing 0 and a decimal. What about 4.0? 2 sig figs, 2 sig figs. You know how many you're allowed to keep your final answer? It's 2. 12 is 2 sig figs, yes, 1 and 2. 3.00 times 4.0. This is 3 sig figs now because you have trailing zeros. There's 2 of them in the end. 4.0 is still 2 sig figs. So how many are you allowed to keep? Well, it depends on your weakest measurement. You're only allowed to keep 2. 4 sig figs times 3 sig figs. So how many sig figs are you allowed to keep now? You're allowed to keep 3. Weakest measurement. So 12.0. Also, when we get that 0.0 on the end, we have more precision now because our original measurements have more precision. 4 sig figs times 4 sig figs allows us to keep 4. How many sig figs is 3? How many sig figs is 4? So how many are we allowed to keep? Only one.
Oh.
10 is only one sig fig. You can't keep the 1, 2 because that's 2 sig figs. And we don't know that for sure. Because when someone's like, it's about 3 times about 4, we don't know that that's 12 for sure. We know it's about 10. When someone's like 3.0, like we know that it's a 3 for sure, and 4.0, we know that's a 4 for sure, then all of a sudden they can say that's 12. But when you're like, it's like 3, but it might have been 2, it's like 4, but it might have been 3, we're like, well, all right, then it's about 10. Let's try this exercise. You don't have to write this down necessarily, or you could write SF for sig fig if you wanted. So it's 3 sig figs times 2 sig figs. How many sig figs would you be allowed to keep regardless of the numbers? Only 2. 6 sig figs times only 2 sig figs you'd be allowed to keep. What about 3 times 3?
3.
What about 6 sig figs, a really precise measurement, times a really crappy one, 1 sig fig?
1.
Only 1. Okay? Now, you guys just learned the multiplication rules, but you didn't realize you also learned the division rules. If I were to go ahead, and the only thing that's going to change on my next slide is the multiplication symbols in the middle there are going to change to the division symbols. And this is exactly the same. The answer is exactly the same. So 6 sig figs divided by 2 sig figs is going to be 2 sig figs. 6 sig figs divided by 1 sig fig is going to be 1 sig fig. So the rules are identical for multiplication and division. They're identical. They are identical. Let's talk about rounding real quick, and I'll let you guys practice on your own. Okay. So if you were to plug this into your calculator, 135.82 times 17.00, you would get this answer right here. That is the answer you would get. Okay? So it's a little over 2,000. Now, what if Mr. Workman was only allowed to keep 5 sig figs? Well, he'd be like, okay, 1, 2, 3, 4, 5. Or 5 right here. He'd have to round after that 9. Does that 9 round up or down? Down. So here's what he'd write as his final answer. 2,308.9. What if he was only allowed to keep 4 sig figs? Okay, does that 9 make that 8 round up or down? Up. So now, 4 sig figs would be 2,309. Do you notice how the size of the number isn't really changing, but we're just changing where we rounded? Okay, so still a little over 2,000. Around 2,000. 3 sig figs, so we have to round after this 0 right here. Does that 0 round up or down? Up, right? And so this would be 2, 3, and some people are going to be tempted to put 231. That changes the size of the number completely, okay? See how that changes the size of the number? We're not chopping off the numbers, we're simply rounding them. So you got to include that 0 there. But Mr. P, didn't you add a, wait, no, that's not an added sig fig, right? As long as we don't put the decimal. It's still 3 sig figs, we're fine. For 2 sig figs here, we'd have to round after this 3. Does the 3 round up or down? Down. And so we have 2,300. Again, the size of the number isn't really changing. And lastly, if we were only allowed to keep 1 sig fig, we'd have to round after this 2. Does the 2 round up or down? And so 2,000. Again, the overall size of the number is about 2,000 the whole time. So it never shrinks to 200 magically because we accidentally chopped something off. We're just rounding. And so what I always say is rounding is more like smoothing over with zeros, not chopping. So we're smoothing over with zeros, not chopping, not chopping. Smoothing over, not chopping. And so that brings us to here. Calculations involving significant figures. Okay. So you guys should now be able to do the multiplication and the division stuff. You will notice that the bottom half of this worksheet on the back has addition and subtraction. Completely ignore that today, okay? I did not teach that to you. I'll teach it to you tomorrow. But you guys can do the top half of the back part of the worksheet, these 2 sections right here. Your quiz tomorrow will not have any sig figs on it, nothing like that. It's just the bell work from today, conversions only. But your quiz on Friday will have sig fig stuff on it. Okay? So that's a wrap right there.